Okay, as we mentioned, we are starting a new unit today on inequalities. So instead of equations, we're going to start talking about inequalities. I do not. I'm out of pencils. Let's see if somebody has one for you. Anybody have a pencil you can borrow? Thank you. Okay, so when we talk about numbers, okay, every number we've dealt with so far in Algebra 1 has been based on one symbol, the equal symbol. But in reality, when we talk about comparing any two numbers, A and B, whatever those numbers are, there are three different ways that we can compare those numbers. Either A can be less than B, A can be greater than B, or A can be equal to B. Okay, there are three different ways that numbers can interact. They can be equal, A can be greater than B, or A can be less than B. So far this year, everything we've done has been based on that second situation where A is equal to B. But now we're going to go into inequalities, which means we need to be familiar with these other signs. Okay? Now, when we're first taught this should be review. When we're first taught this in grade school, we are taught about the alligator mouth, right? That symbol kind of looks like a Pac-Man, like a mouth, right? And that mouth always wants to eat the larger number. Okay? So whatever two numbers we're looking at, whichever way the mouth is trying to face, that is the bigger number. Okay? The bigger number, it's always going to try to eat the bigger number. So whichever number is bigger, that mouth should be trying to eat. Okay? So first thing we've got to be able to do is correctly use these symbols. Those four examples underneath what I've written down here, those three symbols could be used to compare any two numbers. For instance, on example 1, if we look at negative 5 and positive 7, which of those two numbers is bigger? Negative 5 or positive 7, which number is bigger? 7. 7 is bigger. So we should be putting the less than symbol in between those two numbers because negative 5 is less than 7. Okay? Negative 5 is less than 7. That's what that says in words. Negative 5 is less than 7. Okay, how about the next one there? Which number is bigger, 14 or 8? Yeah, 14 is bigger. So that mouth would be trying to eat 14. Okay, in words that would read 14 is greater than 8. 14 is greater than 8. Now, with integers, with whole numbers, with negative numbers, that's not very difficult, right? It is not very hard to just plug one of these symbols in between two numbers. But integers are not the only numbers that we need to be familiar with. We're in high school, so we need to be familiar with integers, decimals, fractions, positives, negatives. Eventually, we need to be comfortable with exponents, square roots, but not yet. Okay? So that next problem there, 15 over 3 and 5. Those numbers are the same because 15 over 3 is 5. If they are the same number, then we put the equal sign in between them. Okay? In words, again, this would say 15 over 3 is equal to 5. We've been dealing with equals all year. Okay? Try example 4, please. Try example 4. So, which number's bigger? -6 or -3? Good. -3 is the larger number. Okay, -3 is the larger number of those two. So we should put the less than symbol between -6 and -3. Okay, -6 and -3. Okay, -6 is less than -3. Okay, when in doubt, think about the number line. Okay, if you think about a number line, whichever number is further to the left is smaller. Whichever number is further to the right is larger. Okay? Now, there are two other symbols that we are going to see when we use variables. Okay, those symbols are shown here at the bottom of the page. Does anybody know what that top symbol is? Less than or equal to. This symbol means less than or equal to. Okay, what about the one under it? What does this symbol mean? Bottom one. Greater than or equal to. Because when we do not know the actual value of a number, when we're dealing with a variable, it is technically possible that we would have to consider 2 out of our 3 possible states. So that means there's a total of 5 symbols we might need to use when we're solving something in algebra. Greater than or equal to, less than or equal to, and less than. Okay? So we have a total of 4 new symbols, and by new, they really shouldn't be brand new. They should be new for this class, but not for the first time that you've ever seen them. Greater than, less than, greater than, equal to, less than, equal to. Okay? All right, so now we're going to take these symbols, we're going to graph on a number line. This is a relatively simple idea that, again, we probably should have at least some experience with. From junior high, okay, even from first semester, for some of us, we did this. Okay? Now, when we graph on a number line, whatever number is indicated will have a circle at that number. Okay? If we are using less than or greater than, that is an open circle. If we are using less than, equal to, or greater than, equal to, that is a closed circle. Okay, the reason for that is whether or not that number is actually included in the solution. If it is less than or equal to, that number is a possible answer. But if it is just less than, then it's not. Okay? So when we go in here and we solve example 5 and we graph x is less than 2, that's what that says. X is less than 2. Okay, we go down to our number line and we put 2 right in the middle. Okay? Now, we list some more numbers. What are some numbers that are bigger than 2? 3, 4, 5, right? What are some numbers that are smaller than 2? 1, 0, -1, Okay, so that we label our number line. Yes? Now, this is a less than symbol, which tells us open circle at that value 2. So we just go in and we circle the dash mark that is at 2. Okay, so put a little circle. Okay? Then, if x is located on the left, which it is, the symbol itself points the direction that we're supposed to shade. Because any number that is smaller than 2, less than 2, could be in this solution, could be part of the answer. So see how this is sort of pointing to the left? Yeah? That means we're supposed to shade to the left, which includes the arrowhead on the end, because any single number in that shaded region could answer this inequality. So we put an open circle at 2, and we shade to the left. Okay? Next example. X is greater than negative 2. X is greater than negative 2. So again, we are going to put negative 2 right in the middle of our number line. Okay? What are some numbers that are bigger than negative 2? This is tricky. Negative 1, 0, 1. Okay? Going the other direction. Negative 3, negative 4, negative 5. Okay, we need to get those numbers on that number line so that we can graph. Now, this is a greater than symbol. It does not have the or equal to line, right? If there's no line, that is an open circle. And we're going to put that open circle at negative 2. So again, we go in and we circle negative 2 on our number line. Now this time, it says x is greater than negative 2. So instead of shading this way, which is less than, to the left, we're going to shade to the right, which is greater than. That's all there is to this. Okay, this should be very, very simple, very, very easy. Okay, shade in, and don't forget to shade in the arrowhead. Okay, nice and dark. Okay. What's different on example 7 there? Yeah, we've got a or equal to line. Okay? This says x is less than or equal to 5. Which means 5 is part of the answer. When we have that line, that tells us we have a closed circle at 5. My at symbol's terrible there. There we go. Okay. So 5 right in the middle of the line. Couple numbers bigger, 6, 7, 8. Couple numbers smaller, 4, 3, 2. And at 5, we put a circle, but we fill it in. Because we have that or equal to, that is a closed circle. Okay? And then it is less than or equal to, so the symbol itself is pointing to the left, meaning we shade left. Okay? That is how this works. Everybody try example 8. Go. Okay, as I walk around the room, the big problem I'm seeing is we're having trouble labeling the number line. Remember that -3 is going to go right in the middle somewhere. Numbers that are bigger than -3 are -2, -1, and 0. Numbers that are smaller are -4, -5, -6. Okay, continue. Let's keep trying example 8. Those of you at home, pause the video, finish trying it first. All right, so this says x is greater than or equal to -3. So we put a closed circle at -3 because -3 is included. Anytime we have that line, that is a closed circle. Okay, this line right here, the or equal to, that tells us it's closed. Then the symbol itself is pointing to the right. So we should shade to the right. Okay? If we look at that symbol is pointing the directions that we're supposed to shade. It's pointing to the right. Now, that is where we run into the trick question. Example 9. What does that say in words? 3 is greater than x, which means we're going to have a problem if we try to do it the way we've been doing it. See, what that means is that if 3 is greater than x, x is less than 3. Okay, if we switch the left and right sides of an inequality, that mouth is still going to try to eat the bigger number. So if we switch the 3 and the x, that mouth is still going to stick to the 3. It's still going to try to eat that 3. Okay? So it's important to realize that the x has to be written on the left side. Okay? From there, this is no different than what we've done. This says x is less than 3. So we put 3 in the middle, which means 4, 5, 6 or bigger, 2, 1, 0 or smaller. Is that an open or closed circle? Good. There is no equal to symbol. So that is an open circle at 3. And now that x is on the left, it shows us which direction to shade. We should be shading to the left, the less than side. So we'd be shading to the left, okay? That's one of the major ways that math will try to trick you, is it will switch the x and the number and put the x on the right side. If it does that, you just need to mirror image to flip the whole statement. And remember, the alligator mouth will always eat the bigger number. So if we start with the mouth trying to eat the 3, and we switch the sides, that mouth is still going to try to eat that 3. Okay, one more example like that. If we see this example 10 and it says -2 is greater than or equal to x, then we can flip that whole statement around and rewrite it as x is less than or equal to -2. Okay, those are the same exact statement. Okay? So, again, that says x is less than or equal to -2. So we want -2 to be right in the middle of our number line somewhere. Numbers that are bigger than -2 are -1, 0, 1. Numbers that are smaller than -2 would be -3, -4, -5. Now we have that less than or equal to symbol, so should our circle be open or closed? Closed, so we have a closed circle at -2. Okay, and then now that it's written in the correct order with x on the left, which way are we supposed to shade? Left. Okay, remember that symbol, it points the direction we are supposed to shade. Everybody see it? It's pointing to the left. X, okay, is less than or equal to -2. That is pointing to the left. So we shade to the left. All right, that does it for that section. Okay, any questions before we advance? Now what we have just done is we have reviewed middle school inequalities. Okay, that was not Algebra 1, that was pre-algebra. Okay, so now we're going to go into the Algebra 1. If you turn that page over, now we can start talking about the Algebra 1, now that we've covered that background information. Okay, so inequality symbols can be treated exactly like the equal sign when it comes to solving equations and inequalities. Solving an inequality is exactly the same as solving an equation with one very small difference. Okay? There's only one difference, and that is when you multiply or divide by a negative number, yep, I need to write this down. We must flip the inequality. Meaning that less than would turn into greater than and vice versa. Okay? So anytime we multiply or divide by a negative number, we have to flip the inequality. Otherwise, this is exactly the same as solving equations, which we have been doing for several months. Okay? So this should be relatively simple. Now the other major difference is that when we finish solving, we're going to have to graph our solution on a number line. Okay? So those are our two differences between solving inequalities and solving equations. Okay. So get that written down and then we can start through these last couple of examples. All right, let's try one. Okay? Example 11 says x plus 5 is greater than 6. Okay? We are going to treat this exactly like an equation. Okay? So for instance, if you have this equation, x plus 5 equals 6, how do you solve that equation for x? Yeah, we just have to subtract 5. Guess what? Absolutely no difference from this equation. In the inequality, we do exactly the same thing. So in the equation, we would go, oh, I need to subtract 5 from each side, right? And I would get x is equal to 1. Yeah? Well, an inequality behaves exactly like an equation in all but one situation. So when we look at this, we still go, oh, I need to subtract 5 to get x by itself. Now, subtracting 5 is not multiplying or dividing, right? So it behaves exactly like an equation. And we just have a different symbol. That's the only difference, is that we end up with x is greater than 1. Instead of an equal sign, we just have a greater than symbol. But we know how to do this. We know how to solve equations. Okay? Now, the other difference is we have to graph it. This is our answer, but we have to graph it. So, that says x is greater than 1. That means that our circle is going to be located at 1. So go ahead and get your number line labeled. Should run something like -2 to +4, something like that. Okay, and then we have a greater than symbol, which tells us open or closed. Open, very good. That is an open circle at 1. And which way do we shade? To the right. Very good. Okay? So it's just us combining that last skill with solving equations, which we've done a lot. So our answer is x is greater than 1 and the graphed number line. Both are required in order to consider the problem complete. Okay? How about example 12? What do we need to do to get x by itself? We need to add 15. Okay, we need to add 15 to each side of the equation. That would cancel out the 15 on the left and give us x is greater than 28. Now 28 is a bigger number than we've dealt with, but doesn't really change anything. Okay, we still label our number line, which can get a little crowded. 28 goes right in the middle. Open or closed? Open. Shade left or right? Right. Okay. So we have an open circle at 28, and we shade to the right. Okay, this is how this works. Try example 13, please. Those of you at home, pause the video. Try example 13. Okay, go ahead.
I saw a few of you do this on your calculator.
Okay.
That is not that. You've got one too many. We need to do -4 minus 3. So make sure you do the right number of minuses and negatives on your calculator. That's what I...
All right, so to undo +3, we need to... Okay, what do we need to do to solve this? Subtract 3. Okay, it says +3, so we do the opposite, which is -3. Now, we're still not multiplying or dividing, so we still don't have to worry about the difference between an inequality and an equation. It still behaves exactly like an equation. So that would give us x is greater than -7 for our solution. -4 minus 3 is -7. Okay? So we put -7 in the middle. A couple numbers that are bigger than that would be -6, -5, -4. Okay, a couple numbers that are smaller, -8, -9, -10. Okay, then we go to the graphing part. Open or closed? Open. Okay, shade right or left? Which way is that symbol pointing? To the right. Okay? X is greater than -7. Now I realize all three of these have shaded to the right. That is coincidental. Okay, we got to think about this every single time. So there's our first 3. Okay, let's go on and try to get at least one or two more in, and we may actually skip around a little bit so we can see some of the multiplication and division. All right, we're going to skip example 14 because we've seen several that are addition and subtraction. We're going to go to example 15. How do you solve that inequality? That says 3 times x, so we need to divide by 3. Now, this is where that possible problem arises. When we multiply or divide, we have to think to ourselves, the number that we are dividing by, is it negative? Is that 3 negative? No. So we still don't have any differences. It still behaves exactly like a regular equation. X is greater than 2. So 2 goes in the middle. We label our number line. Open or closed? Open. Which way do we shade? Right. Okay. So that one's not really any different. It's just a multiplication, so we have to divide. How about example 16? How do we solve that? Divide by negative 2. Okay. Ding, ding, ding. There's our special case. When we divide by a negative number, we have to flip the inequality symbol. It was greater than. It is now less than. That symbol up here gets flipped. Okay, we're dividing by a negative, so our greater than symbol flips and becomes a less than symbol. X is less than negative 4. When we divide by a negative, we have to flip that symbol. Other than that, no different in terms of graphing. Okay, is that an open or closed circle? Still open. Do we shade to the left or the right? Left. Okay, that symbol, the purple one, is pointing us to the left. Okay? All right, I want you to try examples 17, 18, and 19, please. All 3 of them. 17, 18, and 19. Try all 3. In the meantime, I'm going to go ahead and go through example 14. To solve that one, we need to add 2 to each side. Since we're adding, it is not a special case. And we are left with our answer, x is greater than negative 1. So negative 1 would go in the middle, which would allow us to label our picture, open circle at negative 1, and shade to the right. And I'm realizing that I made these notes relatively quickly, so all of them are open circles, which I'm not real happy about, but there's not much I can do about that at this point. Remember that if it's less than or equal to, greater than or equal to, they'd be closed circles. Otherwise, all of this process is the same. Matter of fact, I think we're going to fix that problem. We're going to add some greater than or equal to's right there on 18 and right here on 17. We're going to change those symbols on our video to make sure that we have a couple of good examples of this. Okay? Okay, so we ran out of time in class, so here's the rest of the lesson. We will cover this tomorrow, Friday, before I give out the homework assignment. So, on example 17, that says 5 times x is greater than or equal to, because I just changed it, 15. So we would divide by 5 in order to solve for x. That would give us x is greater than or equal to 3. That means 3 needs to be in the middle of our number line. We have a closed circle at 3, and we would shade to the right. Again, that arrow will point us in the correct direction. So x is greater than or equal to 3, and the graph is also part of the solution. Now on the next one, that can be a little bit tricky. That says x is divided by negative 3. So to undo division, we need to multiply by negative 3. Now since we're multiplying by a negative, our symbol, which is currently greater than or equal to, has to flip and become less than or equal to. So that would give us x is less than or equal to negative 3, which means negative 3 needs to be in the middle of our number line. Since it is greater than or equal to now, yes, I changed that, it is a closed circle, and we shade to the left. All right. Final example. That says x divided by 4, so to fix that, we multiply both sides by 4. Since 4 is positive, we do not have to deal with the symbol changing, and we just have x is greater than negative 12. So negative 12 would go in the middle of our picture, which means negative 11, negative 10, negative 9, negative 13, negative 14, and negative 15 would be the numbers on the line. Open circle at 12 and shade to the right. Okay, so the homework assignment will be posted as well. That's what we're going to be doing in class tomorrow. So this will be for today and tomorrow. Thank you very much for your time and attention.